Okay, welcome. This is another related rates problem. So in this question we have two cars. One's traveling east, one's traveling north at different speeds. Both cars are approaching the same intersection. So let's try to draw a picture to see what's going on. This point here, this will be the intersection. Okay. So car A is traveling east, so that would be in this direction towards this intersection. So car A must be over here somewhere. And then car B is traveling north towards this intersection, so it must be down here somewhere. And it's going up like this, car A going in this direction. So car A is traveling at 40 kilometers per hour, and car B is traveling at 60 kilometers per hour. Both cars are approaching this point I. And we want to know at what rate is the distance between the cars changing when car A is 500 kilometers, or 500 meters. 500 kilometers would be really far. 500 meters, and car B is 1 kilometer, so 1 kilometer. Let's just get this in the same unit. So instead of saying 500 kilometers, let's say 0.5 kilometers. So 500 kilometers is the same as or 500 meters is the same as half a kilometer. So we want to know how fast the distance between A and B is changing. So that would be this diagonal right here. So let's give these letters. Let's call x the distance between A and the intersection, and y, so x is distance from car A to the intersection. I'll just call it I. And then y is distance from car B to intersection. And then actually we need a third variable. That would be the distance between A and B. And z is distance between A and B. Okay, so now we need to, let's write down what we know. Well, we know how fast dx dt is changing, right? We know that x is changing at a rate of 40 kilometers per hour. And actually, if you want to be proper about it, x is actually getting smaller because the distance between A and I is actually decreasing. So we're going to say it's decreasing at a rate of 40 kilometers per hour. And the same thing for dy dt. And again, that would be this distance, and again it's getting smaller, so I'm going to say it's decreasing at a rate of 60 kilometers per hour. And then what we want to know is dz dt. So what does that equal? It's our question. When x is equal to 0.5 kilometers and y is equal to 1 kilometer. So now we need an equation which relates x, y, and z, which hopefully you recognize would just be Pythagorean theorem. X squared plus y squared is equal to z squared. So really what we want to relate is the rates, not just x, y, and z. So how would we do that? We differentiate both sides with respect to t. So the derivative of x squared with respect to t is 2x, but variables are different, so it's implicit. So multiply by dx dt plus 2y dy dt for the same reason, and 2z dz dt. Now, just to make our calculations easier, we can divide both sides of this equation by 2. So we'll get x dx dt plus y dy dt equals z dz dt. Now let's just sub in our knowns and our unknowns, right? What do we know? Do we know x? Yes, 0.5. Do we know dx dt? Yes, negative 40. Y, 1, know that. Dy dt, negative 60, I know that. Z I don't know, and dz dt I don't know. So there's two unknowns here. So it's a bit of a problem, right? You only want, we just want this to be a known because that's what we're looking for. So we need to figure out what z is before we can figure out what dz dt is. Well, just remember from up here, we know, remember x squared plus y squared equals z squared. So we're looking for it at this instant when x is equal to 0.5 and y is equal to 1. So let's just put that into Pythagorean theorem. 0.5 squared plus 1 squared equals z squared. Then we can find what z is at that instant. So 0.5 squared would be 0.25 plus 1 equals z squared. So it would be 1.25 equals z squared. So z would equal the square root of 1.25, which is equal to, we'll round that to, let's go with 2 decimal places, which would be 1.12 to 2 decimal places. So now let's just sub everything in. So x was 0.5, dx dt was negative 40, y was 1, dy dt was negative 60. That was equal to z, which was 1.12, times dz dt. So now it shouldn't be too difficult to just solve for dz dt. So we have minus 20 minus 60 equals 1.12 dz dt. So it would be minus 80 z by dt. So then just dividing everything by 80, negative 80. Oh, sorry, that's not right. We want to divide by 1.12. So that goes away. So dz by dt is equal to negative 80 divided by 1.12, which is equal to negative 71.4, and then the units on that were kilometers per hour. So you've got the distance between A and B is changing at a rate of negative 71.4 kilometers per hour. So let's just go back. So this distance is changing at a rate of negative 71.4 kilometers per hour. So a question I would ask here is, why is this negative? Does that make sense? And if you think about it, the reason it's negative is because the rate is, for the same reason we made these negative, the rate is decreasing. Meaning, what does that tell me about A and B? It tells me that A and B are getting closer together, which is exactly what should be happening, right? This distance is shrinking, so we get a negative rate. Then does that answer? Yes, that answers. So the distance between the cars is changing, is decreasing at a rate of 71.4 kilometers per hour.